All right, everybody, welcome to the video here for lesson number 3. If you noticed, I also posted a video going over the entire lesson of lesson number 3 in case you were absent or you missed something, because lesson number 3 is vital for you to be able to do everything for the rest of this chapter. So the first question asks us about radii, diameters, and chords of this random circle M. So it says list 3 segments that are radii of a circle. So a radii is going to start at the center and go to one of the endpoints of the circle. So MR is going to be a radii of the circle. It's a segment, so we'll draw it like a segment. MQ is a radii of a circle. And MT is going to be a radii of a circle. One of the things that's important about radii is they're always going to have the center as one of the 2 pieces there. And then it says list a segment that's a diameter of a circle. So the diameter is going to be a chord, so it has 2 endpoints on the circle, but it's also going to pass through the center. So notice here's the center, so TMQ passes through the center, so we'll say TMQ. I could just say TQ, and if you did TQ, it's not wrong. I'm just going to include M so that we know exactly where it's passing through. The last question says to list a chord that is not the diameter of the circle. So a chord is going to have endpoints on the circle, so QS has endpoints on the circle, but notice it does not pass through the center, so QS would be considered a chord. Number 2 says in circle K, A, B, and C lie on a circle. Which of the following would not be a chord of the circle? So this is really just requiring you to be able to draw an appropriate diagram. So here's circle K. It says A, B, and C are on the circle. So here's A, here's B, and here's C. It doesn't really matter where you put them. A to C would be a chord because it has diameter, or it has 2 endpoints on the circle. B to C would be a chord because it has 2 endpoints on the circle. K to C, well, that starts from the center and goes, this is a radii, so that's not a chord. A to B would also be a chord. No matter where I drew A, B, and C, all 3 of those choices would be chords. Choice 3 would always become a radii. Number 3 tells us that we have circle O, and it says points A and B lie on the circle, and it doesn't tell us that they're opposites of each other or that they create a diameter, so I'm just going to put them in random places. But the one thing that I do know is they're the same size because they both represent the radii, so that means this expression and this expression are equal. So I can say 5x minus 11 is equal to 4x minus 4. Where I'm getting 4x minus 4 from, I'm distributing into the parentheses just like I would have done in algebra. If I then subtract 4x and use my algebra skills here to try and find x, I have x minus 11 equals negative 4 plus 11, and I get x equals 7. Don't get too excited because that's not my answer. It wants us to find the length of the diameter. So if I plug in 7, I can figure out what OA is. So OA is 5 times 7 minus 11, so that's 35 minus 11, or OA is 24. Again, don't get too excited, that's not your answer. OA is just the radius. I know that the radius is half of the diameter, so the diameter is going to wind up being 48. So a good thing to talk about with this multiple choice question is don't get distracted by getting answers that are choices. You have to make sure that you really read through the whole thing. So this really wants the diameter here. So let's make sure that we're really looking at the diameter here the whole time. Number 4 says in circle L, points E and F lie on the circle such that E, F, and L are not collinear. That means they're not on a straight line. And then says that LE and LF and EF are all drawn, which must be true about the triangle. So let's talk about what this picture looks like. Because again, this is really just, can you draw the appropriate picture? So circle L has a center of L. It says E, F, and L are not collinear, meaning if I put point E here, F is not going to be opposite it to make a diameter. It's going to be somewhere else, so it's not on the same straight line. So we're going to have this triangle that's formed like this. I know that these are radii, so that means those two segments are congruent, meaning triangle LEF must be isosceles. Could it be a right triangle? Sure. Could it be an equilateral triangle or an obtuse triangle? Sure, but it has to be isosceles, right? I could redraw this so that E and F were closer together or further apart. So if I made like E and F here and made L over here, this would be an acute triangle, where if I made them far apart, I can make it so that it's an obtuse triangle. I can make it any of those things, but every one of these triangles is going to be isosceles. Number 5 asks us about arcs. So one of the things that we learned today is that minor arcs are less than half of the circle, major arcs are more than half of the circle. So part A asks to list a minor arc and a major arc that have points L and M as their endpoints. So L and M, if we just put LM, is going to be this small arc from L straight to M. So LM is a minor arc. A major arc would have to start at L and go counterclockwise to N and then to M. So I could say this is L, N, M as the arc. The minor arc. So now that we have the minor arc and major arcs from L and M, let's talk about the major arcs and the minor arcs from L to N, which are going to be a little bit different. So from L to N, I could just say arc LN. Right, that would be this piece here. The major arc, I'd have to go clockwise, so I'd have to start at L and go pass through M to get to N. So this would be L, M, N. The last question, we're actually going to finally start doing some numbers. So it asks us to find a bunch of different arcs in this diagram. It starts by giving us the central angle DAB, and it says to find arc BD. So since it's a central angle, I know central angles are equal to the arc. So then we can say 48 degrees is arc BD. That's an easy one. The next arc they asked us to find is DC. Now, if you notice, BAC is the diameter of the circle, meaning it cuts the circle in half. So that means if I take 180 degrees, which is half a circle, and subtract 48, I'm left with 132 degrees for that arc. Arc BC is half of a circle, so that would be 180. And then it asks us to find a couple different arcs that are kind of a combination. So arc DBC is a major arc. So if I start at D, go to B, and end at C, I see this big yellow arc is going to be a combination of the 180 arc and the 48 arc. So that's going to wind up being 228 degrees. Arc DCB is going to start at D, go through C, and then end at B. So that arc is going to be the 132 and the 180. So if I add 180 and 132, I get that arc. Now the other way of doing that one would be subtract 360 and 48, because the whole circle's 360, and then if you subtract the arc that we're not looking for, it would be 312. Either way, you wind up getting the same exact answer. Notice in this homework, we didn't talk about inscribed angles much, and that's because, well, guess what? We're going to do a lot more of that tomorrow, right, in the next lesson. Hopefully this video helped. Keep working on your Regents Review assignment, which is on Google Classroom, and we will talk about that all at the end of the week.